Hi, my name is Lea Nicklas, and I'm presenting today how Galacto-Oligosaccharide supplementation mitigates extreme feather damage in stressed laying hens. So let's talk about extreme feather damage. It's considered an iceberg indicator by the European Food Safety Authority Panel on Animal Health and Animal Welfare, and it's primarily caused by severe feather pecking, a behavior that is a multifactorial problem in laying hens. And you can see here that it occurs across housing systems. So I'm showing feather cover damage, those bald patches that you can see, in an aviary style housing, in a backyard flock, and in an enriched colony. Now, severe feather pecking behavior involves one hen repeatedly pecking and plucking the feathers of another hen. And on the side of the hen that performs this behavior, there are many causes. It can be endogenous factors. It can be frustration if hens, for example, are not able to forage or perform other highly motivated behaviors. And exogenous stressors also cause severe feather pecking and even outbreaks. On the side of the hen that is the receiver or the victim of this behavior, the reason it's considered an iceberg indicator for animal welfare is because it can cause thermal discomfort, so cold stress in particular, as hens lose feather cover. When feathers are plucked out, this can also be painful for the receiving hen. And of course, a loss of feather cover can impair locomotion, such as flapping flight, especially important in housing systems with 3D locomotion, like aviaries. Of course, this also has economic impacts, negative economic impacts, and it can cause societal concerns. So, what do we know about severe feather pecking behavior? We know that hens that either have been genetically selected for this behavior or that happen to perform it phenotypically have an altered gut microbiota, especially this genus Lactobacillus seems to be deficient in their gut. Their immune system is also characterized by a pro-inflammatory status. And at the level of the brain, we know that their brain chemistry has changed. In particular, the serotonin metabolism seems to be deficient. All of this points us towards the microbiota gut-brain axis as a way of potentially influencing severe feather picking behavior. And indeed, a previous study has shown that supplementing laying hens with Lactobacillus rhamnosus JB1, so specific probiotic strain, can prevent increases in stress-induced severe feather pecking in laying hens. Now, I don't work with a probiotic, I work with a prebiotic. It's called galacto-oligosaccharides. And prebiotics essentially are non-digestible substrates to the host, the chicken, that feed the gut microbiota in a way that confers a health benefit to the hen. My galacto-oligosaccharides chemically are sugars linked in a chain, and this makes them pretty stable during processing, transport, and storage, making them a viable on-farm solution for feather pecking. Now, from the rodent literature, we know that these galacto-oligosaccharides increase the growth of Lactobacillus and Bifidobacterium, two beneficial strains, you often see them in yogurt, in the gut of the rodents. They also enhance serotonergic tone in the brain, and they've been shown to be associated with reduced expression of anxiety-like behavior in behavioral tests. Now, we don't know what happens when you feed them to hens, but we hypothesized that one effect could be that they change the gut microbial composition of our hens, thus influencing the availability of aromatic amino acids that act as precursors for neurotransmitters in the brain like serotonin and dopamine, and thereby could alter feather picking behavior and the resulting feather cover damage during times of social stress. To test this hypothesis, I worked with 191 laying hens. At the beginning of my baseline period, they were 27 weeks of age, so in lay. 105 of them were genetically selected against severe feather pecking behavior. These are the low feather peckers. And 86 of them were genetically selected for the expression of this behavior. So they have an internal predisposition to perform it, although the heritability of feather pecking is low to moderate. But when we house them together in floor pens like we do, and we mix them between the lines, we have some hens that might peck and others that do not, which mimics industry conditions. For my experimental timeline, I have a 1 week baseline period, followed by a habituation to the supplement only, because as we all know, when you change your diet, that takes a bit of getting used to. So we wanted to give our hens time to adjust to this increase in non-digestible dietary fiber. Then we had a 21-day treatment period. and today I'm focusing only on the feather scoring, so the feather damage outcomes. We measured these at the end of the baseline period and the end of the treatment period, but my study did also investigate feather pecking behavior itself using video observations. We looked at egg quality, egg production, feed disappearance, body weights, and then of course we also wanted to investigate potential mechanisms by looking at aromatic amino acids, the microbiome, and even serotonin and dopamine concentrations in the brain, as well as some immune organs. But today we'll focus only on the feather cover damage. For my treatments, you can see here how we offered them. So 6 of my pens received control, plain water, while the other 6 pens, so the other half, received the supplement in the water. We used a 3% inclusion rate relative to the estimated daily feed intake per hen, and this was based off of a broiler study that's been previously done since there's not been a laying hen study yet. We supplemented on 5 days per week for 21 days during the treatment period. And then on 3 random days per week, half of the hens in each of the water treatments, so the water control or the supplemented water, underwent social mixing to induce social stress. This was done by repeatedly mixing hens between pens to maximize the number of encounters with unfamiliar individuals. This is a potent stressor that's been shown to increase severe feather pecking behavior previously. And we only ever mixed within treatment groups. So supplemented hens only encountered supplemented hens, and control hens only encounter control hens. For my feather damage scoring, we used the method developed by Decina et al. We looked at 5 distinct body areas that were all scored by a single blinded observer at both time points. Scores are 0 to 2. A score 0 looks like this for the head and neck shown here, none to slide wear. For the same body area, a score 1 would look like damaged feathers and or bald patches less than the diameter of a $2 Canadian coin shown here for reference. And then for a score 2, this is my most severe score, you can see that the bald patch now is larger than the circumference of the $2 coin. For the statistical analysis today, just because it's much easier visually to grasp, I'm showing a calculation of the overall worst score per hen per period. Again, we had our one blinded observer, and I just wanted to show the kappa score as well to show that we had substantial agreement for this scorer. Our overall worst score is calculated as follows. If a hen has one score of 1 in one body area, her worst score is 1. If this score is a 2, it becomes a 2. So it's not cumulative, it's the single worst score that a hen had in any body area. We then used multinomial models with odds ratios to model the outcome of worst feather cover damage across treatment periods and across all 4 treatments. We also then looked at the outcome of being in the worst feather score category as well. Now, let's look at where we started. At the baseline period, 28 weeks of age, my hens had a comparable distribution of feather damage scores across all of the 4 future treatment groups. This means that in my flock there's evidence of feather pecking, but most birds had no feather damage, shown in green in the bar plots at the bottom. You can see the 4 different conditions, and I'm only showing the baseline bars. Some of them had mild feather damage already, shown in yellow, and very few had severe feather damage. So this is pretty evenly distributed. It's not out of control yet, but there is some feather pecking. Now, when we move to the post-treatment time point at 32 weeks of age, we can see that the pink and yellow increase. So those are scores 1 and 2 at the bottom. You can see now the baseline and the treatment scores. Across all of our hens, the odds of worse feather damage were 28% higher at the end of treatment compared to the baseline. This means that feather pecking continued and predictably the scores worsened. Additionally, there was no difference between the 4 treatment groups following our treatments. Now, if you'll recall my scale, you can see that scores 0 and 1 are really no to mild damage. From an animal welfare perspective, as the score 1 appears, we start to worry about feather pecking. However, once you have a score 2, there's severe damage and the impact on animal welfare is much more drastic. So we wanted to know, what are the odds of a hen ending up in this most severe category where cold stress, pain, and issues locomoting might occur? When we investigated the severity of damage, so moving into category 2, we saw that our Galacto-Oligosaccharide supplemented hens had 78% lower odds of having this most severe score compared to our unsupplemented stressed hens. Now, in the absence of stress, this effect was not present. So only under stress did we have this buffering effect of the galacto-oligosaccharides. This means that galacto-oligosaccharide supplementation does not prevent the overall worsening of feather damage. It does not stop feather pecking. But under chronic social stress in our laying hens, it appeared to protect against the progression to the most severe feather damage scores. This is actually consistent with previously published research that showed that a live probiotic, Lactobacillus JB1, a specific strain, reduced stress-induced increases in feather pecking in hens. And when you look at microbiome research where no stress treatment was used, we can see that using Lactobacillus LR32 or a synbiotic containing lactobacillus also decreased severe feather pecking behavior. And feeding black soldier fly larvae, which influence the microbiome due to their chitin exoskeleton, can also reduce severe feather pecking. So this all points us towards the microbiome as one way of mitigating severe feather pecking and the resulting feather damage. The takeaway from my talk today is that supplementing laying hens with galacto-oligosaccharides offers no apparent benefits in the absence of stress, at least when we look at the feather cover damage. However, it does appear to buffer stress-related escalation to severe feather damage. This means that it could be a viable supplement to offer to hens when we know that they're undergoing a period of stress, as it may help protect them from this most severe feather damage, even when feather damage was already present. And this, of course, is beneficial to prevent welfare risks. Thank you so much for listening, and thank you to my advisor, Dr. Alexander Harlander, the co-authors, collaborators, my lab mates, and a special thank you to the funding partners that made this work possible, as well as the staff at the Poultry Research Station here in Guelph that look after our laying hens. Thank you.